In today's math lesson, we're going to find the number of solutions. This is a curious little concept and thus lesson, only to discover that your equation might not have any solution. It might have one solution, or it might have infinitely many solutions. So let's go find out how to determine what your equation does. Your equation will have no solution if you solve for x and discover that you have something really weird. It's weird in a way that it is a false statement. A false statement will cause all of the x's to cancel out, leaving you with just numbers. And these numbers will be not true. For example, 3 equaling 7. Well, no, it doesn't. Or -4 equals +4. Well, no, it doesn't. So if you end up with something weird like this where there are no x's at all and the numbers don't match, then you have an equation that has no solution. You will know if your equation has one solution when you solve for x and if you get an answer that looks normal. Like, what do you mean normal? Like, for example, x equals 17, perfectly normal. Or really, truly, x equals any number, that will be one solution. Finally, you will know if your equation has infinitely many solutions if you solve for x and then you get something weird, but it's a true statement. So for a true statement, again, all of your x's are going to cancel out, leaving you with just simple numbers. But these numbers will match. They will be the same. It will be a true statement because 5 does equal 5. Or -37 really does equal -37. So to be infinitely many solutions, the numbers have to match and all of your x's are gone. Example 1. How many solutions does the equation have where 0 equals -10d plus 10d? Well, we've learned a lot in the last few lessons about solving for a variable. And we know, well, we've learned that when you have multiple of a variable on the same side of the river, to just combine them. That gives us 0 equals -10d or dogs plus 10d or dogs. Well, -10 plus 10 makes 0. And this is a true statement. Because 0 does equal 0. And we learned in the introduction that whenever you get a true statement, yeah, it's weird, all of your variables have canceled out and the numbers match. 0 does equal 0. Therefore, that particular equation has infinitely many solutions. And there you go. Example 2. How many solutions does this equation have where -4h equals -2h minus 2h? So it's really important to be solid on your skills of solving for an equation for a variable. And we remember from previous lessons that if you have multiple of the same variable on the same side of the river, you can go ahead and combine them. So -4h on the left equals, what is -2 minus 2? Well, that is again -4h. And we can stop right here and we can say that this all by itself is very much a true statement. We can cause the h's to completely cancel out, getting us back to a final answer of 0 equals 0. But we can see already, this is -4h equals -4h. Yeah, the variables are the same, the coefficients are the same. Therefore, both the left and right sides of the equation match, and we have infinitely many solutions. Example 3. How many solutions does this equation have where negative 3s equals negative 3s minus 8. Here I have variables on both sides of the river. So we need to get them all onto one side of the river. And we learned in a previous lesson that to do that, we do the opposite of what's currently happening. So currently this is minus or negative 3s. So we're going to add it over to the other side of the river. The purpose of that was to get the 3 s's on the right side of the equation to cancel out. But in turn, what it did is it says negative 3s plus 3s here on the left side of the equation. Well, that canceled out all of my variables, leaving 0 equals negative 8. Now, is this a true statement? Does 0 equal negative 8? No, not at all. So this is where we said all of the variables are gone, but the numbers do not match. Therefore, our false statement tells us that this particular equation has no solution. And there you go. Example 4. How many solutions does this equation have? Where 2y minus 16 is equal to negative 11y plus 13y minus 4. Are your solving skills being extra tested in this lesson? I bet they might. Since we have the same variable more than once on the right side of the river, let's go ahead and combine them. So on the left, I have 2y minus 16 equals. What is negative 11 plus 13? Yes, that is still 2y minus our 4. There it is. Okay, so I've combined the like terms on one side of the river, but now I need to get all of my terms to the same side of the river. So let's go ahead and subtract 2y that's on the right side of the river. I knew to subtract because this 2y is positive. And what I do on one side of the river, yep, we got to do to the other side of the river. And the whole point of that was to cancel out these 2 y's that are there on the right side of the river. But we see that here on the left side of the river, these 2 y's also canceled out, leaving us with negative 16 equals, what's here on the right side? Negative 4. Oh, well, all of my variables have canceled out. And do we have a true statement or a false statement? Well, negative 16 does not equal negative 4. This is a false statement. And as a result, we know that this particular equation has no solution. And there you go. For our fifth and final example, we are asked if this particular equation is an identity, where negative 3 minus 7j is equal to negative 7j minus 3. This word identity is new for us. Let's find out what it means. To be an identity, an equation needs to be a true statement when it is solved for the given variable. So let's go ahead and solve it. We have the variable j on both sides of the river. So let's get started by moving one of them. On the left side of the river is a minus 7j. So we're going to move it to the right side of the river by doing its opposite. And what you do on one side of the river, yep, you do it to the other side of the river as always. The whole point of this was to make the j's on the left side cancel out. And that happens to leave you with negative 3 equals, hey, the j's on the right side of the river canceled out too. So that negative 3 equals another negative 3. And yes, all of our variables have canceled out, and negative 3 is equal to negative 3. This is most definitely a true statement. Thus, we can say without any question, yes, this is an identity. And there you go.